So take a look at this question. The question is asking you to write a complete ionic equation and a net ionic equation for this reaction above. So first of all, we need to understand what exactly is a complete ionic equation and what's a net ionic equation. So it turns out whenever you see a reaction written in this form out here, what the reaction is showing is it's showing that each of the entities out here, each of the molecules out here, they're actually complete molecules, meaning it's trying to show you that the HI exists in combination with the iodine. That means there's an actual bond between the HI. So it's saying that, okay, there's that bond, and then the BaOH2 would look something like this. Ba with the OH, sorry, just beside it, and there's another OH beside it, so it'll kind of look like one entity, another entity, and you can go on so on with this. The reality is it doesn't exist like this. So anything that has an AQ beside it actually exists as ions. So the HI exists, kind of looks like this. Sorry, that's what am I doing? The HI looks like this. It exists as an HI plus, H plus, and an I minus. And then the BaOH2 exists as Ba2 plus and 2OH minus. Okay. So when the question says that, hey, write the complete ionic equation and net ionic equation, the first thing we need to understand is, and let me change the color of this pointer. The first thing we need to understand that what's given to us right this out here, the complete balanced equation as we normally see it, that is the molecular equation. Okay, so this equation is a molecular equation. The next step is to take that molecular equation and break it down into its constituent ions, and that would be the complete ionic equation. Okay, so the only ones that we're going to change into ions are the ones with the AQ in parentheses, so those three. So let's go ahead and write that down out here. So the 2HI becomes 2H plus, and make sure you put the AQ in parentheses around it. Sorry, to the right of it, plus 2I minus, plus, now we go break down the BaOH twice as Ba2 plus AQ plus 2OH minus AQ. And on the other side of the equation, on the product side, we keep the H2O intact because that does not have an AQ beside it, so we keep that as 2H2O. And for the BaI2, that's again an AQ, so that's going to be Ba2 plus AQ plus I minus, and there's two I minuses, so we'll write them as 2I minus AQ. All right, so what you have out here is your complete ionic equation. Okay, so let's write that down. This is my complete ionic equation, and I'm going to abbreviate this as CIE. Okay, now from the complete ionic equation, the next step is to go to the net ionic equation. The net ionic equation simply means we will cancel out all the ions that appear as common ions on both sides. Okay, so take a look at the 2I minus. It appears as 2I minus on the same side on both sides, so therefore this would get canceled out. Okay, so let's go ahead and do that. So 2I minus cancels out. Ba2 plus also appears on both sides in an identical fashion, so those two get canceled out, and nothing else shows up that can be canceled out. So it turns out the ions that we canceled out, we actually have a special name for them. These are called spectator ions, and the reason for that is because they kind of hang out and do nothing in the reaction. They do have a role, but for the purposes of writing a net ionic equation, we cancel them out because they're not playing a role, okay, out here. So That's why they're called spectator ions. Okay, so the net ionic equation is going to be what's left out, left over. So 2H plus 2OH minus gives us 2H2O, and that is your net ionic equation, also abbreviated as NIE. All right, let's do another problem. Let's zoom in a little bit so we can focus on this problem. Okay, same instructions out here in this problem. We have to write the complete ionic equation and net ionic equation. What we have is the molecular equation. I'm going to abbreviate the molecular equation as ME. Let's break this down into its constituent ions, only the ones with AQ. So 2Ag plus 2NO3 minus plus Mg2 plus AQ plus 2Cl minus AQ. That gives us, we're not going to break down the 2AgCl because it's a solid, okay? So we write it as is, 2AgCl plus Mg2 plus AQ plus 2NO3 minus. Next step is to cancel out the spectator ions. The NO3s go away, the Mg2 pluses go away. And let's write down, so that was our complete ionic equation, this one. Now let's finally write down the net ionic equation, which should be 2Ag plus, but forgot to put an AQ out there, AQ plus 2Cl minus AQ gives us 2AgCl solid. And there you have it. All right, now let's take a look at another example where we're asked to write a molecular equation and a net ionic equation for the reaction that occurs between this compound, aqueous HBr, and aqueous LiOH. Now, it turns out this is actually an acid-base reaction, okay? And you need to be able to recognize an acid-base reaction, okay? So this is an acid and that is a base. When acids and base react, one of the very common reactions that take place is a neutralization reaction, okay? So the neutralization reaction between an acid and base always produce salt and water, okay? So we can write it out this way: an acid plus a base always gives you a salt plus water, okay? And the water component out here is actually a liquid. So, but everything else is going to be in aqueous form, okay? So that's going to be AQ, that's AQ, and that's AQ, okay? So now that we know that, the next thing to know is this acid and this base, are these strong acids and bases, okay? And why we want to know if it's a strong acid or base? Because if it's a strong acid or base, it will undergo 100% dissociation. And so which ones are the strong ones? This is the list of strong ones that you will see. So the acids would be all the HBr, HCl, HI, HNO3, H3PO4. Okay, so these are the common strong acids. Here's another one, HClO4. Common strong acids, let me write another one, H2SO4. Okay, so these are the common strong acids. Okay. Strong acids. Okay. Now, strong bases would be any group 1 or group 2 hydroxide. If we look into group 1 or group 2 hydroxide, it's a strong base. So what we mean by that is group 1 will be any element in group 1 of the periodic table. So we're looking at lithium, OH, NaOH, KOH, and so on. Okay. Group 2 would be CaOH twice, BaOH twice, and so on. Okay. So these are the strong ones. Okay. Now anything that's not out here, assume it's weak. And usually when you encounter a weak one, the quest at for GenChem 1, the question will actually tell you it's a weak one. Okay. All right. So now that we know we have that background information, the question is saying write out a molecular net ionic equation. So let's go ahead and write the molecular equation first. So HBr is a strong acid. So we write HBrAq plus LiOH AQ. And since it's an acid-base reaction, it's going to undergo a neutralization. And for us to understand what kind of neutralization it's going to undergo, let's go ahead and take the HBr and write out the ions that's going to form. So that's going to be, I'll just write them right below this, H plus, Br minus. The LiOH is going to form Li plus, OH minus. Now I'm going to switch the ions around. So I'm going to crisscross applesauce to kind of predict the product. So let's combine the H plus with the OH minus. That's going to give us water. So that's going to be H2O, liquid, plus. And then the remaining two, it's going to be LiBr. That's going to be the salt, LiBr. And that is going to be AQ. All right, so there is our molecular equation. Call that Me. Now, the next they want you to figure out, write the net ionic equation. You cannot write the net ionic equation unless you write the complete ionic equation. So, since we already have the H plus, the ions corresponding to these written out here, I'm just going to elaborate this and write out the net ionic equation. So that's going to be H plus Br minus, don't forget the AQ, plus Li plus AQ, plus OH minus AQ, gives us H2O, will stay as is, plus LiBr, going to be Li plus AQ, plus Br minus AQ. Now let's cancel out the spectator ions. Li plus goes away, Br minus goes away. That leaves us with H plus AQ plus OH minus AQ gives us H2O, liquid. And there you have it. That is my net ionic equation. Hopefully that made sense. Okay, we'll look at one more problem before we wrap up this video. This problem actually asks you to write a net ionic equation for the reaction between this compound, which is a weak acid, and NaOH. So now, since this is a weak acid, it's still going to be an acid-base reaction, but you have to assume that most of it does not ionize, which means that when you write out the equation, so let's go ahead and write out the equation, then we'll show you what that means. So NaOH is a strong base, so that's going to form these ions, Na plus, OH minus, and this one, a few of them are going to form ions, so we're going to write a few ions that form. So that's going to be H plus and CHO2 minus, and then we're going to crisscross them to predict the products. This is going to form NaCHO2 aqueous, plus the H plus and OH minus is going to form H2O, liquid. All right, so let's go ahead and write out the molecular equation for this. So that's going to be HCHO2 aqueous plus NaOH aqueous gives us NaCHO2 aqueous plus H2O, liquid. All right, now that's my molecular equation. I'm going to write the complete ionic. The complete ionic is going to be HCHO2 aqueous will remain as is on the left, and that is because of this assumption, assuming that most of it does not ionize. Okay, So, but the Na plus NaOH ionizes into Na plus and OH minus, and then this one, of course, ionizes. It's a salt. So Na plus aqueous plus CHO2 minus aqueous plus H2O liquid. All right, now it's time to cancel out the spectators. So that's going to be these two go away, nothing else can be cancelled. So you have your net ionic equation, which is HCHO2 aqueous plus OH minus aqueous gives us CHO2 minus aqueous plus H2O liquid. And there you have it. Okay, hope that made sense. Thank you for watching.